Question 283. Oil is leaking out of the tanker in the shape of a circle at a constant rate. At a certain instant, the rate of increase in the area of the circle is exactly twice the rate of increase in its circumference. What is the radius in centimeters of the circle at that instant? Okay, in order to solve the related rates problem, first be sure to draw a picture that explains the situation in this problem. Okay? Well, oil is leaking out of the tanker in the shape of a circle, right? So we start with a circle. So draw a circle. Okay, here is radius R. And this circle is increasing, right? Then it says the rate of increase in the area of the circle is exactly twice the rate of increase in its circumference. This means dA over dt, change in area with respect to time t, is equal to 2 times dc, circumference c, over dt. Right? This is given, right? Okay, the question is, what is the radius in centimeters of the circle at that time, at this time, right? Okay, the area of a circle, A is equal to pi r squared, and circumference is equal to 2 pi r, right? We all know this. Okay, so let's differentiate each of these equations with respect to time t. So differentiate with respect to time t. So dA over dt is equal to, pi is constant, right? So leave pi alone, pi times power of 2 times r times the derivative of r, dr dt, right? Let's differentiate this equation right here. Okay, so we have dc over dt is equal to 2 pi is constant, right? So 2 pi times the derivative of r with respect to t, dr dt, right? Okay, so 2 pi times the dr dt, that is equal to dc over dt, right? Here we have 2 times pi times the dr dt, right? So all of this expression is equal to dc over dt. So we're going to substitute dc over dt for 2 pi dr dt. So let's write dA over dt is equal to r here, right? R times 2 pi dr dt, that's dc dt. So dc over dt. So far so good. And it was given that dA over dt is equal to 2 times dc over dt, right? This expression, this derivative, is equal to 2 times dc over dt. So I'm going to write this is equal to 2 times dc over dt. Okay, so let's rewrite this equation right here. 2 dc over dt is equal to r times dc over dt, right? Cancel this out. So what is our radius? Radius is 2 centimeters. Okay? Question 387. At what rate is the volume of a cube changing at the instant when the surface area is 54 square inches and each edge is decreasing at the rate of 0.5 inches per second? Okay, we'll start solving the problem by drawing a cube. So here we have cube, right? Okay. So let the edge of the cube be x. X here. Okay. The question is to find the rate of the volume of the cube when the surface area is 54, right? And it is also given that each edge is decreasing at the rate of 0.5 inches per second, right? If edge is decreasing, the rate must be negative, right? Think about this graph right here. Let's say this is time t, this is edge x. If this is decreasing like that, what is its derivative? I mean the sign of its derivative. Its derivative is negative, right? So this must be negative, right? So let me erase this. So it is given that dx over dt is negative 0.5, negative 1 over 2 inches per second, right? So far so good. Here it is also given that surface area is 54. So surface area. Surface area is, the area of each face is x times x squared, right? X squared. So we have 6 faces. So that's 6x squared. And we're going to find the rate of a volume when this is equal to 54. Okay? So the volume, the equation of the volume is equal to base times the height. X times the height, x cubed, right? So let's differentiate with respect to time t. So we have dv dt, change in volume with respect to time t, is equal to, we have to apply the power rule, 3x squared times chain rule, derivative of x itself, dx over dt, right? Okay. When the surface area is 54, then x has to be 3, right? So we're going to substitute 3 here. And dx over dt, that's given. That's negative 1 over 2, right? So substitute negative 1 over 2 for dx over dt, right? So our dv dt is equal to 3 times 3 squared times negative 1 over 2. So that's going to be negative 3 cubed, 27 over 2, right? What's the unit? It's volume over time. So cubic inches per second, right? Question 395. A 15-feet ladder is leaning against the vertical wall. The base of the ladder is being pulled away from the wall at the constant rate of 2 feet per second. At what rate is the top of the ladder moving down the wall when the bottom of the ladder is 9 feet from the wall? Okay, let's draw a picture that explains this situation. So we have a vertical wall, and let's say this is ground, and we have a ladder here leaning against the vertical wall, right? So this is a wall. Okay, it says the base of the ladder is being pulled away from the wall at a constant rate of 2 feet per second, right? So here is the base of the ladder, and this is moving this way, right? If we let this variable as x, then it is given that change in x with respect to time t, that is equal to 2, right? 2 feet per second. And it is a positive 2 because this length is increasing, right? So since x is increasing, it's a derivative, its rate is positive 2. So far so good? Okay, as this base moves this way, then top of the ladder will move down, right? So it'll move down. And the question is, what rate is the top of the ladder moving down? when the bottom of the letter is 9, when x is equal to 9, right? So we're gonna let this variable is equal to y. Okay, so the question is to find what's dy over dt when x is equal to 9. That's the question, right? Okay, the length of the letter is always 15. This one doesn't change. The length of the letter doesn't change. So we have to write that as a 15 constant, right? So let's write the equation now. So using Pythagorean theorem, we're going to write x squared plus y squared is equal to 15 squared. Okay? Now let's differentiate this equation with respect to time t. Okay? So derivative of x squared, power o, times derivative of x with respect to time t. So we have to have a dx over dt, right? Y squared, 2y power o times the derivative of y dy dt is equal to derivative of constant is always equal to 0, right? So divide each term by 2, which means we can just eliminate this, right? And the question is to find dy over dt when x is equal to 9, right? So when x is equal to 9, using Pythagorean theorem, we can find the value of y, right? Here, 9 is 3 times 3. 15 is 3 times 5, right? Both of these numbers have 3 as their factor, right? Then, just look at this number right here, a small number, 3, 5. If we have a 3 here, 5, our hypotenuse is 5, then what is this length? That's going to be 4, right? Using the Pythagorean theorem. So that's going to be 4. But this number is multiplied by 3. This number is multiplied by 3. Then also multiply by 3 here. So that's going to be equal to 12. Which means when x is equal to 9, y is equal to 12. Alright? So far so good? Okay. So we're going to substitute 9 for x. So 9 times dx over dt, that's 2, right? Plus y, 12, dy dt, that's what we are looking for, right? So 12, let me write down here. 12 dy over dt is equal to 9 times 2, negative 18, right? Okay, 6 times 2, 6 times 3. So dy over dt is equal to negative 3 over 2, right? So when x is equal to 9, the top of the letter, which is here, right here, top of the letter is moving down at a rate of 3 over 2 feet per second, right? So the top of the letter moving down at a rate of 3 over 2 feet per second. Okay? Question 396. At what rate does the angle of elevation between the ground and the level change when the bottom of the level is 9 feet from the wall? Okay, the angle of elevation between the ground and the level is this, right? And we're gonna write angle theta here. And the question is asking us at what rate does the angle change, right? So they're asking us to find d theta over dt, change in angle with respect to time t, when x is equal to 9 feet from the wall. 9, right? So far so good? And it was also given that dx over dt, right? dx over dt was 2. Here, constant rate of 2 feet per second, right? Okay, now we're gonna write the equation. But that equation must include theta, right? So we're gonna use a trig, either sine or cosine or tangent. Which one should we use? We want to include theta, of course, and x, since dx over dt is given. Okay, so we're going to use cosine. Cosine is adjacent over hypotenuse, right? So let's write cosine. Theta is equal to adjacent over hypotenuse. So far so good? Okay, so let's differentiate this equation. Okay, so derivative of cosine is negative sine, right? Negative sine theta, we're not done yet. We have to multiply by the derivative of theta itself with respect to time t. So we have to multiply the theta over dt, right? That's chain rule. It's equal to, well, x over 15. We don't want to apply the quotient rule here, right? X over 15 is just 1 over 15, constant times x, right? So when we find the derivative of x over 15, leave the constant alone, multiply by derivative of x, which is dx over dt, right? So dx over dt, that's 2, it is given. We have to find this. And what's sine theta when x is equal to 9? Remember, when x is equal to 9, we found out y was 12, right? So at this point, sine theta is opposite over hypotenuse, right? 12 over 15. So minus, let's erase this, minus sine theta 12 over 15 times the theta dt is equal to 1 over 15 times 2, right? So eliminate 15 divided by 2, this becomes 6 then, right? So our d theta over dt is equal to negative 1 over 6, right? Negative 1 over 6 radians per second. This is angle, okay? So the angle is decreasing. If our derivative is negative, we must say angle is decreasing at a rate of 1 over 6 radians per second, okay? Question 397. At what rate is the area of the triangle formed by level, the wall, and the ground changing when the bottom of the level is 9 feet from the wall? So the question is asking us to find the change in area of the triangle, right? So we must write the equation of the area of the triangle. Area of the triangle is just equal to 1/2 times base times the height, right? So base times the height, x times y, right? So we're gonna differentiate this equation. And remember, it was given that dx over dt is equal to 2, right? Constant rate of 2 feet per second right here. Okay, let's differentiate this equation with respect to time t. So dA over dt is equal to, leave constant alone, and we're going to have to apply the product rule to find the derivative of this, right? Because x is a variable, x is changing, and also y is changing too, right? So we're going to apply the product rule. You know, derivative of x, that's not 1, that's dx over dt, and y here plus x times the derivative of y, which is dy over dt, right? And remember, we found out dy over dt when x was 9, right? From the question 395. dy over dt was negative 3 over 2 feet per second, right? Okay, so when x is equal to 9, we know that y is equal to 12. So we're going to substitute those informations. 1/2 here, dx over dt, that's 2 times y is 12 plus x is 9 times dy over dt, that's negative 3 over 2. So far so good. So that is equal to 1/2 times 24 minus 27 over 2. So that's going to be equal to 1/2 times 21 over 2. Right? So that's going to be, you can use your calculator, okay? That's going to be 21 over 4. So we can say the area of this triangle, this is positive, is increasing at a rate of 21 over 4 feet squared. The unit is a feet squared, the area, right? Per second. Okay? Question 398. There is a water tank in the shape of inverted cone. The tank has a radius of 8 feet and a height of 14 feet. If the tank is being filled with water at the rate of 4 pi cubic feet per minute, how fast is the water level rising when the water is 4 feet deep? Okay, let's start with the inverted cone. So here we have inverted cone, right? Okay, this cone has radius 8 feet, so this is 8, and height 14, right? So this is 14, right? And the tank is being filled with water at the rate of 4 pi cubic feet per minute, right? If we have a cubic feet, then that must be volume, right? So the change in volume with respect to time t is 4 pi, right? So water is coming to this tank, and dV over dt is given. That's 4 pi cubic feet per minute, right? So the let's say we have this much of water here. Okay. I'm gonna let this radius is r. The height of water is h. Okay. The question is, how fast is the water level rising when the water is 4 feet deep, right? So the question is asking us to find dh over dt, change in height with respect to time t when height h is equal to 4, right? That's the question. Okay, so we're going to start with the equation with the volume of the cone. So volume of the cone, V, is equal to 1 over 3 base times height. Base is a circle, so pi r squared times height, right? Okay, if we differentiate this equation right here, we will have dV over dt here, and here we have two variables here, right? R, as water comes into the tank, R changes, radius of water changes, right? Height changes, right? So these two are variables, they changes. So if we differentiate this expression right here, we're gonna have to apply the product rule to find the derivative of this, and then we will have dr over dt from here, also dH over dt from here, right? We'll have too many unknowns. Do you guys see that? So we're going to have to transform this equation before we differentiate this equation. Okay? So here, if we look at this figure right here, let me draw a line like this. As you see it, this triangle right here, this small triangle, they are similar triangles, right? Because the angle from here to here, the angle from here to here, they're the same. And they are sharing this angle, right? So by AA similarity, these two triangles are similar. Okay? So let's write the proportion. Here, when we have radius here, let's say R to H is equal to radius over height, 14, right? 8 over 14, radius over height, right? So that's going to be equal to 8 over 14 divisible by 2. So 2 times 4, 2 times 7, right? So R is equal to 4 over 7H. So far so good? Now we're going to substitute this expression for R here. Then we'll have the equation of a volume in terms of H, right? So let's rewrite this equation. Volume is equal to 1 over 3 times pi, that's pi over 3. And R is equal to 4 over 7H, right? So 4 over 7H squared times H. So if we rewrite this, that's going to be 4 squared 16 pi over 3 times 7 squared 49, right? And we have H squared times H, that's H cubed. Our volume is equal to, now in terms of H, 16 pi over 3 times 49 H cubed, right? Now we're going to differentiate this equation with respect to time t. Okay? Then what we have here is dV over dt is equal to, this is constant, right? So leave this one alone. 16 pi over 3 times 49, and derivative of h cubed, that's power of 3h squared times derivative of h itself. That's a dH over dt, right? Okay, we're almost done. dH over dt, dV over dt. This is given right here. That's 4 pi, right? So 4 pi is equal to 16 pi over here. This 3 cancels out, right? So we have 16 pi over 49, and h is 4. We're trying to find dH over dt when h is equal to 4, right? So we're going to substitute 4 for h. So 4 squared here times dH dt, right? So let's simplify this. Here we're going to eliminate pi, 4 times 1, 4 times 4, right? So that's going to be 49 over 4 is equal to 4 squared times, or 16 times dH over dt. So dH over dt is equal to 49 over 4 times 4 squared. That's 4 cubed, 64, right? So dH over dt is 49 over 64. Okay? So the height of the water is increasing at a rate of 49 over 64 feet per minute, right?